Hello again. In this video, we're going to use L'Hopital's rule in cases involving infinity. So here it is. L'Hopital's rule applies to limits involving infinity, provided f and g are still differentiable, and a is any real number, or a could be plus and minus infinity. So when you have the limit as x goes to a, when they both go to plus or minus infinity, or when the a is infinity, meaning when you take the limit as x goes to infinity of f of x, which is equal to the same limit as x goes to infinity of g of x, which is equal to 0. You can use L'Hopital's rule. So let's check out the second case here, when the a is infinity. So I'm going to let f of x be the numerator and g of x be the denominator. If we look at the limits as x goes to infinity to each of these, you can see that the numerator does go to infinity because we have a 5x there. The second term does go to 0, but infinity plus 0 is infinity. And the same with the second one. If we look at the limit as x goes to infinity of just 7x, it's definitely infinity. So what we get is an infinity over infinity situation. And that fits this definition, or this condition. And that does make sense, because if you put this as 1 over 0, you put this as 1 over 0 and then flip them, you would end up getting a 0 over 0 situation. So let's go ahead and find that limit. So since I'm satisfied all the conditions of L'Hopital's rule, I'm going to use L'Hopital's rule. And we're going to get the derivative of the numerator, which is just 5. And that would be e to the negative x, but times negative 1. And the derivative of the bottom is 7. You can see this is not going to go to 0 over 0 anymore. In fact, this is going to go to 5/7, since e to the negative x is the same as 1 over x. And as x goes to infinity, this whole term right here goes to 0. So that's it. The answer is 5/7. And we can test this on our calculator by plugging in the original function in the y equals button, then go to second table set, making sure that you're on ask, and then going to table and typing in large values. You can see as x gets larger, it gets closer and closer to 5/7. So let's calculate this limit. The limit as x goes to infinity of x times e to the x. We see that that is not quite in the right form, but if we just manipulate this just a little bit, now it is in the right form. The numerator goes to infinity, the denominator goes to infinity, so we can use L'Hopital's rule. That would be 1 over e to the x, and you can see as x goes to infinity, this whole thing goes to 0. We also can use it in this situation. This is actually a kind of interesting situation. We're going to let y equal 1 plus 1 over x to the x. And I realize that that is also not infinity over infinity, but I can manipulate this as well by taking the ln of both sides. And notice how you can bring down that x now. Now, this is a better form, but it's still infinity, and this would be ln of 1, which would be 0. But at least I can manipulate it. I can put x down in the denominator by making that 1 over x, which is the same thing. Now I'm going to get a 0 over 0. So I'm going to take the limit of both sides here. And I know on the right side I can use L'Hopital's rule, so that's 1 over this inside quantity times the derivative of the inside all over the derivative of the bottom. And again, the reason I can use L'Hopital's rule is because the value of the top going to 0 is 0, and the value of the limit of the bottom goes to 0. These cancel. So we end up with is just the limit as x goes to infinity of this 1 over 1 plus 1 over x. And that, by the way, goes to 1, because 1 over x goes to 0. And what we get here is something interesting. This means as x goes to infinity, ln of y goes to 1. And that means e to the ln of y goes to e to the 1, but this is just y. So y is going to e. So that means that the limit, therefore the limit as x goes to infinity of just the y is equal to e to the 1, or e. If we go back to the original, this is how we define e. Hope that helps.